Monitoring a file until a string is found. I am using tailf to monitor a log file that is being actively written to. When a certain string is written to the log file, I want to quit the monitoring and continue with the rest of my script. Currently I am using when the string is found, grep quits as expected, but I need to find a way to make the tail quit too so that the script can continue.
Here is a simple one-liner. It doesn't need bash-specific or non-POSIX tricks, or even a named pipe. All you really need is to decouple the termination of tail from grep. That way, once grep ends, the script can continue even if tail hasn't ended yet. So this simple method will get you there. Grep will block until it has found the string, whereupon it will exit. By making tail run from its own sub-shell, we can place it in the background so it runs independently. Meanwhile, the main shell is free to continue execution of the script as soon as grep exits. Tail will linger in its sub-shell until the next line has been written to the log file, and then exit, possibly even after the main script has terminated. The main point is that the pipeline no longer waits for tail to terminate, so the pipeline exits as soon as grep exits. Some minor tweaks. The option N0 to tail makes it start reading from the current last line of log file, in case the string exists earlier in the log file. You might want to give tail F rather than F. It is not POSIX, but it allows tail to work even if the log is rotated while waiting. Option Q rather than M1 makes grep quit after the first occurrence, but without printing out the trigger line. Also it is POSIX, which M1 isn't.
The accepted answer isn't working for me, plus it's confusing and it changes the log file. I'm using something like this. If the log line matches the pattern, kill the tail started by this script. Note, if you want to also view the output on the screen, either vertical bar t/dev/t, or echo the line before testing in the while loop.
If you're using bash, at least, but it seems it's not defined by POSIX, so it may be missing in some shells, you can use the syntax. It works pretty much like the FIFO solutions already mentioned, but much simpler to write.
There are a few ways to get tail to exit. Poor approach. Force tail to write another line. You can force tail to write another line of output immediately after grep has found a match and exited. This will cause tail to get a SIG pipe, causing it to exit. One way to do this is to modify the file being monitored by tail after grep exits. Here is some example code. In this example, cat won't exit until grep has closed its spout. So tail is not likely to be able to write to the pipe before grep has had a chance to close its stin. Cat is used to propagate the standard output of grep unmodified. This approach is relatively simple, but there are several downsides. If grep closes stout before closing stin, there will always be a race condition, grep closes stout, triggering cat to exit, triggering echo, triggering tail to output a line. If this line is sent to grep before grep has had a chance to close stin, tail won't get the SIG pipe until it writes another line. It requires write access to the log file. You must be okay with modifying the log file. You may corrupt the log file if you happen to write at the same time as another process. The writes may be interleaved, causing a new line to appear in the middle of a log message. This approach is specific to tail. It won't work with other programs. The third pipeline stage makes it hard to get access to the return code of the second pipeline stage, unless you're using a POSIX extension such as Bash's pipe status array. This is not a big deal in this case because grep will always return 0, but in general the middle stage might be replaced with a different command whose return code you care about. For example, something that returns 0 when server started is detected, 1 when server failed to start is detected. The next approaches avoid these limitations. A better approach: avoid pipelines. You can use a FIFO to avoid the pipeline altogether, allowing execution to continue once grep returns. For example, the lines marked with the comment #optional can be removed and the program will still work. Tail will just linger until it reads another line of input or is killed by some other process. The advantages to this approach are: you don't need to modify the log file. The approach works for other utilities besides tail. It does not suffer from a race condition. You can easily get the return value of grep, or whatever alternative command you're using. The downside to this approach is complexity, especially managing the FIFO. You'll need to securely generate a temporary file name, and you'll need to ensure that the temporary FIFO is deleted even if the user hits Ctrl+C in the middle of the script. This can be done using a trap. Alternative approach: send a message to kill tail. You can get the tail pipeline stage to exit by sending it a signal like sigterm. The challenge is reliably knowing two things in the same place in code: tailspid and whether grep has exited. With a pipeline like tailf ... grep ... it's easy to modify the first pipeline stage to save tailspid in a variable by backgrounding tail and reading $. It's also easy to modify the second pipeline stage to run kill when grep exits. The problem is that the two stages of the pipeline run in separate execution environments, in the terminology of the POSIX standard, so the second pipeline stage can't read any variable set by the first pipeline stage. Without using shell variables, either the second stage must somehow figure out tailspid so that it can kill tail when grep returns, or the first stage must somehow be notified when grep returns. The second stage could use prep to get tailspid, but that would be unreliable. You might match the wrong process, and non-portable. Prep is not specified by the POSIX standard. The first stage could send the PID to the second stage via the pipe by echoing the PID, but this string will get mixed with tail's output. Demultiplexing the two may require a complex escaping scheme, depending on the output of tail. You can use a FIFO to have the second pipeline stage notify the first pipeline stage when grep exits. Then the first stage can kill tail. Here is some example code. This approach has all the pros and cons of the previous approach, except it's more complicated. A warning about buffering. POSIX allows the STIN and STOUT streams to be fully buffered, which means that tail's output might not be processed by grep for an arbitrarily long time. There shouldn't be any problems on new systems. New grep uses read, which avoids all buffering, and new tailf makes regular calls to flush when writing to stout. Non-new systems may have to do something special to disable or regularly flush buffers.
If you want to support the these as levels